Right, now, okay, let us find the point of inflections of these functions that we have here. Let us find a point of inflection. Let us find a point of inflection. Right, remember the functions is f of x is equals to x to the exponent of 3 minus 4x squared and then plus 4x, right? And now you said that the derivative f prime of x there is equals to 3x squared minus 8x, right? And then plus 4. Right, can I give you just 2 minutes, boys and girls, just to find the second derivative for me? Just find the second derivative for me. Now we have f prime of x there is equals to 3x squared minus 8x plus 4. Now, what will be what? What will be there? The second derivative. Thank you. Right. Boys and girls, now, what is your answer? What is your answer on this one? What is the second derivative if we have f prime of x is equals to 3x squared minus 8x plus 4? Of course, we are going to have what? You remember how to find the derivative? 2 times 3, that will be what? That will be 6x, of course, that is a 6x. And then you have minus what? Minus 8. Is that correct? Because that is 1 times negative 8 is a negative x. 1 minus 1 there. That is x to the power of 0. X to the power of 0 is 1. Now, what is the derivative of 4? The derivative of 4 then will be 0. And of course, the other thing which is very important, you must let what? You must let f second prime of x be what? Be 0. Then we have 6x minus 8 there is equals to 0. And now then from this one you can say 6x is equals to 8. When you move it to other side, it's going to be positive 8. Then divide by 6, then x is there. What is 8? Then of course one can say this one is going to be 4, and then this one will be 3, right? Yeah, one can say 2 into 8 goes 4 times, and then 2 into 6 goes how many times? 3 times. That is why now we have x is 4 divided by 3. Right? Of course, boys and girls, these questions, remember, they can ask you in 2 ways, right? They can ask you to determine the x value at the point of inflections. Now, if they ask you to determine the x value at the point of inflections, this is what you must do. Just going to stop here. This is the x value there. This is the x value there at the point of the inflections, right? Of course, if they ask you to determine the point of inflection, then it means they're expecting you to have the x and the y. Right, now, from here, once you have the x, what do you do now? You take the x, which is 4 divided by 3 there, then you substitute it there in the equation, then you're going to have 4 divided by 3 to the power of 3 there, minus 4, then 4 divided by 3 squared, and then plus 4 there, 4 divided by 3. Now you say equal sign there. Now we can use the calculator to work this one out. Then we are going to have brackets there. That is 4 divided by 3 to the exponent of 3 minus 8 bracket 4 divided by 3 there. This is going to give us what? That is squared, and then plus 4, and then 4 divided by 3. Good, and then the answer there is going to be, let me see this one right. That is minus 4, not minus 8. That is minus 4 there. That is minus 4, right. The answer there is going to be 16. It's going to be 16 divided by 27. Right, now, in decimal, then this is the same as 0.59 or 0.6. Right, now the coordinates of the point of inflection, that will be 4 divided by 3 as well as 16 divided by 27. Right, now, when you look at our function now, let us see where is this one. Where is the point? Now, of course, 4 divided by 3, then we have what? 4 divided by 3. It says that is 1,33. X there will be 1,33. That is x somewhere here, 1,33. And now you said y. y will then be what? 0,5, which is 0,6. 0,6, I think the point will then be here. You can see now these points divide these two graphs. Okay, right. This is the x-intercept and the y values of the point of the, that is the x value and the y value of the point of the inflections, right? We also said that you can also use x is equals to minus b over 2a. Okay. You can also use x is equals to minus b over 2a, right? What is it that you're going to do here? In this case, you just focus on this one to say, okay, fine, let me see. Now, the b here is a minus 8, then you have minus, now minus 8, I divide it by 2, multiply by 3, right? This is going to be positive 8 divided by what? Divided by 6. You remember, that's what we had earlier on, 8 divided by 6. When you simplify this one, that is 4 there, divided by 3. Right, that is the first one. The second one we said, you can just take x, that will be x1 plus x2 divided by 2. Of course, x1 at the turning point there. Remember, we did round it off to the nearest. Let me see what was the value there at that time. That is 2. That is 2 divided by 3 there. And then plus what? Plus 2. Then I divided this by 2. Right, when we add this one, 2 divided by 3. Good. And then plus 2. Then we divide this by 2 as well. We have what? Exactly the same answer, 4 divided by 3. Good. Right. Boys and girls, good. I think you have this one here. Let us quickly look at this, at what we did from the beginning of this session here. Right. Of course, we've looked at features of cubic functions, right? We said when you sketch the cubic functions, you need to look at the x and the y-intercept, which is very important. Y-intercept is a straightforward one, but x-intercept, you need to factorize the cubic equations. How do you factorize the cubic equations? Of course, you need to look for common factor. If there's no common factor, you group the terms because you'll be having 4 terms, right? Now, then if you can't work with the one of grouping, then you use the factor theorem, right? And now from that one, we went to the turning points, right? How do we determine the turning point? We said we find the derivative, and now you let the derivative to be what? To be 0. Then you solve for x, and now immediately once you have the x values, now you take those x values, you substitute them where? In the original equation, so that we can have what? You can have the corresponding y value. Right. With that information, of course, now x and the y-intercept as well as the turning points, now you will be able to do what? You will be able to sketch a smooth curve, right, of a cubic functions, right? Hey, boys and girls, we are going to take a break now. During your break, just try to remind yourself these things because they are very important, and then look how different this cubic function it is with the quadratic functions, with hyperbolic functions, as well as the linear equations. They are very, very important if you can be able to differentiate between the three. Right. I will see you after the break, and then now I think we'll look at 2 or 3 examples of the cubic functions.